Good morning, everyone, and welcome to our first lesson in biochemistry. So, the topic is fundamentals of bioenergetics. Particularly, we will be discussing thermodynamic laws, free energy and the energy of activation, endergonic and exergonic reactions, and coupling of reactions. The first topic will be the laws of thermodynamics. So the laws of thermodynamics not only occur in physics, but more importantly, they also apply even in biological systems, like the cells of our bodies and the chemical reactions that occur within the cells. So let's just have a review of the 4 laws of thermodynamics. The first one is the zeroth law, which talks about thermal equilibrium. It says that if system A is in equilibrium with system C and system B is in equilibrium with system C, then system A and B are in equilibrium with each other. So take a quick look at this image below, where box A is physically connected to box C and box C is physically connected to box B. If the temperatures of the 3 boxes are the same at 38 degrees Celsius, then we can say that the 3 of them are in thermal equilibrium. When we say that the temperature of a system is this much degrees, it tells us of the relative activity or movement of the particles in that particular system. So, kapag sinabi nating 35 degrees Celsius, the particles in that system are moving at a particular speed. They are vibrating at a particular speed. But once we increase the temperature to 38 degrees Celsius, then we can also expect that the movement of each particle there increases. So, to sum it up, temperature tells us of the relative motion of each particle in a system. The second law, which is actually labeled here as the first law of thermodynamics, is concerned about the conservation of energy. It says that energy is neither created nor destroyed. So let's take a quick look at this image below. You have system A, represented by box A, which undergoes a reaction so that it will transform into the product B. System B, represented here as box B. If we follow the first law of thermodynamics, it will say that as box A converts to box B, the energy that is contained or held by system A will be the same amount of energy as A transforms to the product B. So what does this tell us? Sinasabi nito na yung mga systems habang sila ay nag-undergo ng chemical reaction, kung ano yung amount of energy sa simula ng reaction, if we contain all of the energy that is released by the reaction and just hold it, save it, the total energy contained in A will be the same as the amount of energy in B plus the byproducts. Okay? So that walang naidagdag na energy, walang natanggal na energy as long as you have a closed system which is able to capture all of the energy. The second law of thermodynamics, which is the third law that we're discussing, tells us about entropy. It says that in the universe, okay, even in biological systems, even in life forms, systems will always move towards increasing disorder. A very good example of that would be a cell. Yung cell, nakaka-divide lang, maliit pa siya, still in the early stages of life. As it progresses through time, as it ages, it will continuously accrue changes that relate to disorder. So for example, in this image, in the bottom, you can see a big circle. As time goes by, it will undergo processes that will lead to that system, that big solitary circle, to form multiple circles that represent increased disorder. So in summary, the second law says that everything will always move towards increasing disorder. At the end of the day, there will be increased disorganization of a system. The third law and the fourth law will be talking about entropy. So if we use the term entropy, we are referring to the degree of disorderliness of a system. So a special form or characteristic of a pure crystal is that if you have a pure crystal and that crystal is placed in a temperature of absolute zero, that means negative 273 Kelvin, that crystal will stop from moving. The particles of that crystal will stop from moving, and therefore it will have zero entropy, zero disorderliness. It is in perfect stillness. It is in perfect organization. So the third law again is the entropy of a pure crystal. A pure crystal at absolute zero has zero entropy. It is perfect. It's not moving. It's the most organized as it can be. Next, let's discuss Gibbs free energy. So, in a system, we have already discussed entropy, which is the state of disorderliness. And that, in the equation, here is represented as S. So S here stands for entropy. H in this equation stands for enthalpy. Enthalpy is basically heat energy. So you have to understand that particles within a system will always have potential energy within them. And this potential energy will be converted into kinetic energy as that particle moves. Okay? So, inherent in each particle as they relate to another particle is enthalpy. So, you can think of enthalpy as the opposite of entropy. To make it simple, if entropy is disorderliness, enthalpy is orderliness. Enthalpy tells of energy that keeps the particles together. It keeps the particles from moving. If you create a change such that the particles absolve or the particles start to move, you need to overcome enthalpy. And as you overcome enthalpy, you release the energy between the particles in the form of heat. So, in summary, enthalpy is the state of orderliness. It's the energy that keeps the particles together. And in order to separate the particles from each other, you need to apply sufficient energy, and that energy is represented as heat. So that's H in the equation. G is Gibbs free energy. After we have added the disorderliness and we have combined it with the orderliness of a system, the energy in disorderliness and the energy that keeps the particles from being disorganized, that's enthalpy, in a particular temperature, we summate it all up, and that will give us Gibbs free energy. What is the total state of energy in the system? That's Gibbs free energy. So if you will look at this equation, Gibbs free energy is enthalpy minus temperature times entropy. You will have a negative Gibbs free energy if you have more entropy in the system and if the system is heated, it has a higher temperature. You will have lesser Gibbs free energy in the system if you have lower entropy and a lower temperature. On the other hand, you will have more negative Gibbs free energy if you have lesser enthalpy, and you will have more Gibbs free energy if you have more enthalpy, delta H. So Gibbs free energy tells us in what direction a particular system will move. If the Gibbs free energy is 0, that means that the system is in equilibrium. The processes in the system that tends to move towards disorder and the processes in the system that tends to move towards orderliness are at equal rates. Therefore, the system will remain in equilibrium. If you have a negative Gibbs free energy, that means that the entropy is really high or the temperature of the system is really high, then the system will tend to lose energy. So, pag sinabi nating negative Gibbs free energy, yung system gusto niyang mag-release ng energy into the environment. And that is what is represented in the image here in the right. So you have the system enclosed by the square, and you have the particles illustrated here. If you have negative Gibbs free energy, then the system will tend to lose heat energy into the environment, and therefore enthalpy decreases, entropy increases. The system will then undergo change so that it becomes more disorganized. So that nature right there, the system becoming more disorganized, is in accordance with the law of entropy na nagsasabi lahat ng systems in the physical universe, even biological systems, will always want to be in a state of disorderliness. So this state of negative Gibbs free energy is in accordance with the law of thermodynamics, and therefore it will be spontaneous. Do you understand? The universe will want to become more disorganized. And so if a system has Gibbs free energy that is negative, it loses heat, it becomes more disorganized. That is what is favored by nature. So a system with negative Gibbs free energy is a system that undergoes spontaneous reaction. Similarly, because these reactions will have to lose heat into the environment. They tend to lose energy into the environment so that they become negative, Gibbs free energy. These systems also undergo exergonic reactions or heat releasing reactions, energy releasing reactions. Okay, so let's recapitulate. Gibbs free energy is represented by this equation. Delta G is equal to delta H, enthalpy, minus the product of temperature and delta S, entropy. The environment and the system are part of nature, even biological systems like cells. And the law of thermodynamics tells us that these systems will want to go into a state of disorderliness. And so, you need to have negative Gibbs free energy to be able to satisfy that law of thermodynamics. You need to release energy into the environment. And by releasing energy to the environment, you satisfy the second law of thermodynamics, then your reaction will occur spontaneously. Because you released energy into the environment, you call that an exergonic reaction. Next, you have activation energy. So activation energy is the energy needed by a system to cause a reaction to occur. It may be supplied or added into the system. And what's important for us in biochemistry is that we have enzymes which are biologic catalysts that reduce activation energy and thus facilitate reactions. Okay, so let's take a quick look in the image here in the right. On the x-axis, you have the reaction progress, and on the y-axis, you have energy. R is the reactant, and P is the product. So you have to take a quick look at R first. R has that particular amount of energy. And P, kung mapapansin nyo, has a lower level of energy. So as R, reactant undergoes reaction and becomes P, the product, mapapansin ninyo that the energy decreases. Anong sinasabi nun? Yung system, which is the reactant R, as it becomes the product, undergoes the reaction, it will throw away into the environment energy. So as it throws away energy into the environment, let's recapitulate yung lesson kanina, that's negative Gibbs free energy. Nagtapon siya ng energy, this reaction is exergonic. And because it is in accordance with the second law of thermodynamics, it is spontaneous. Okay? So, that's the general process. What about activation energy? Sinasabi natin activation energy is needed by R so that it can transform into P through the chemical reaction. You have to see that at the peak of this wave, you have the transition state, which is the state of highest energy. R needs to go into the transition state, and it needs to absorb enough energy to go into that high energy state. And that amount of energy is what we call activation energy. R needs to absorb so much energy so that it moves faster, so that chemical reactions will occur more often. Okay? So you need to reach that transition state, becomes so disorganized at that point, and then it will then release the energy into the environment spontaneously, transforming into the product. So, reactant gain energy up to the transition state. It becomes unstable. Reactions occur. And as the reactions occur, energy is released into the environment. That's a spontaneous reaction. And then, you form the product. So, paano yun ginagawa ng enzymes? Enzymes are proteins, which we will discuss in detail through the succeeding lessons. And what's special about enzymes is that they have three-dimensional shape, and they have three-dimensional clefts, kung saan saktong-sakto yung reactant, doon siya pupunta. Enzymes will because of that three-dimensional shape, maipaglalapit niya yung dalawang reactant together. So because the two reactants are in proximity with one another, then the amount of energy that they have to accrue or absorb is lesser kasi mas malapit sila. So that is represented here in the image by the blue dotted line. So think of that as an enzyme. Dahil mas malapit na ngayon yung dalawang reactants sa isa't isa, konti na lang yung energy na kailangan niya to reach the transition state and therefore undergo a chemical reaction. So that's how enzymes facilitate reactions. They bring the reactants closer to one another so that the activation energy needed is lower. Next, we have already touched with this topic a while ago. Exergonic means the system releases energy. And biologically, okay, these are represented by catabolic reactions. Pag sinabi nating catabolic reactions, a bigger molecule is broken down into smaller molecules, and as that happens, the energy that is contained within the bonds of these smaller molecules are broken down and released into the environment. Okay, so makikita nyo yan in this illustration at the bottom. A bigger molecule degraded into smaller molecules, but at the same time, releasing the energy that is found binding the smaller molecules. And so this is an energy releasing process. And again, your Gibbs free energy here will be negative, and it is in accordance with the second law of thermodynamics. That's why it is spontaneous. Gusto ng nature na mangyari yan. An endergonic reaction, on the other hand, is a reaction that captures energy. So it is represented in the body by anabolic reactions. So in biochemistry, yung mga anabolic reactions, they are endergonic. Pag sinabi nating anabolic reactions, you have small molecules, and then these molecules capture energy from the environment, and this energy is used by the system to form bonds between the smaller molecules to form a larger molecule. So that's an endergonic and anabolic reaction. But again, this is opposite the second law of thermodynamics. And so this is not spontaneous. Okay? So examples of catabolic reactions would be yung glucose molecule. You break it down into smaller sugars, for example, pyruvate, and by converting it into pyruvate, you release energy. An example of an endergonic reaction would be making fats. So the acetyl coenzyme A from intermediary metabolism is continuously connected to other acetyl coenzyme A's to make fatty acids. Okay? So maraming acetyl coenzyme A to make a larger molecule, which is a fatty acid. That's an endergonic and anabolic reaction. So ang tanong, bakit nagkakaroon or paano nagkakaroon ng anabolic reaction na hindi spontaneous? So that is solved by the human body and by the biologic systems through coupling of reactions. So what happens in the coupling of reactions? So the free energy change of the coupled reactions are combined, and the total energy will still be negative. Okay? This occurs so that non-spontaneous reactions, which are anabolic reactions, can occur. So let's take a quick look at this image at the top. At the x-axis, that would be the reaction progress. And the y-axis, that would be the amount of free energy. So unahin nating tingnan yung line A to B. So this reaction is exergonic. The energy in A is high, and as it transforms into the product B, it releases energy. And so that is an exergonic reaction, so that B has a lower energy. Now let's take a look at the line C to D. That is an endergonic reaction. You start from a state of low energy, that's C, and you end up at a state of higher energy, that's D. So what happens here is that for the reaction C to D to occur, you need energy that is released by A to B. So yung A to B na system, it will release energy. And at the same time, the C to D system captures that energy so that it can occur. So that is better illustrated in this image sa baba. So as A to B occurs, energy goes down. E, nasa gitna, cycles from A to B and is transferred C to D. So A to B releases the energy, and C to D captures that released energy so that it occurs. Okay? So that's how the body couples reactions. For example, yung sabi natin kanina, acetyl coenzyme A combined to form fatty acids, anabolic reaction. So, ang nagdadala ng energy sa reaction na yon ay ang reducing equivalent that we will learn later, that is called NADPH. So NADPH is a carrier of energy. And the energy that is held by NADPH comes from the breakdown of glucose in the pentose phosphate pathway. So glucose is broken down in the pentose phosphate pathway. Energy is transferred into NADPH, and kine-carry lang yon ng NADPH at ita-transfer niya kay acetyl coenzyme A yung energy para yung acetyl coenzyme A may energy sila to form bonds with one another, to combine to form fatty acids. Okay? So, through this lesson, I hope you get an overview of bioenergetics, how energy moves in systems. So we have discussed the laws of thermodynamics, and the most important here would be the second law. Then we discussed Gibbs free energy and spontaneity of reaction. And then we have also discussed coupling of reactions. So I hope you learned a lot. Thank you for listening.